Which aqueous solution has the highest boiling point? So highest boiling point is most ions. Okay. So here we have times 2 ions, gives us 0.6 molar ions. Right? K2SO4, there's 3 ions there, 2 potassiums and 1 sulfate. So that gives us a 0.45, right? Potassium phosphate, there's 3 potassiums and 1 phosphate, so that's times 4. Potassium carbonate, that's 2 potassiums and 1 carbonate, so there's 3 ions there, equals 0.45. Right, so the most ions has the highest boiling point, and that is the potassium chloride solution. Lowest freezing point, again, this is most ions. Right, so this is challenging your nomenclature here. So magnesium nitrate, that's MgNO3 2. So that one's going to have 3 ions, so we get a 0.3 molar for that one. Sucrose, that's a non-electrolyte. Okay, that one has no metals and no ions. So we get 1 particle for every molecule, right? So this one's just times 1. So 0.1 molar here. Okay. Aluminum nitrate. Aluminum nitrate should be an AlNO3 2. So we get, excuse me, not a 2, a 3, my bad. NO3 3. So we get 4 ions, so we should end up with 0.4 molar here. And sodium nitrate, that's going to come out as NaNO3. So we get 2 ions there, so a 0.2 molar. All right, so which one has the most particles? That would be the aluminum nitrate. Okay. So our next topic is we're going to sort of get away from this ion business and the colligative properties for a little bit. And we're going to talk about different types of reactions in solution. Okay? So previously we've done some of this, and you've seen all of these reactions before. We've just used slightly different terminology for them. Okay? So precipitation reactions, remember we did these when we did ionic equations. Right? Remember doing complete and net ionic equations and dealing with solubility rules and all that stuff? Okay, so we're going to bring that back around. Acid-base neutralizations, right? Remembering that acids start with H, right? And bases, I'm going to do this down here, and bases have an OH generally. Okay, so you need to be able to recognize when you're dealing with acids and bases coming together. And then the metal displacement, you've seen that one before, but we've called it as a single displacement reaction. Okay, so you'll recognize all 3 of these reaction types. Okay, so this should be an arrow. Sorry, sometimes when I put these things in my device, the symbolism doesn't always come with me. All right, so when I put 2 aqueous things together, the last time we saw this, what did we do? We did a double displacement reaction. So I'm going to trade both of the metals. I'm going to take the sodium and put it with the chlorine, and the aluminum and put it with the phosphate. Okay, and just to remember how that goes, we're going to be putting a sodium plus and a chlorine minus, and then we're going to have an aluminum 3 plus and a phosphate 3 plus, or excuse me, 3 minus. Okay, so I just want to correctly combine those things on the other side. So I'm going to have NaCl, because it's a 1 and a 1 plus and a 1 minus, and just aluminum phosphate, because it's a 3 plus and a 3 minus, so I just need one of each. Okay, then we balance. Right, let me take this stuff out of the way here. Okay, so then we balance. Right, so I've got 3 sodiums on the left, so I need 3 sodiums on the right. And that gives me 3 chlorines on the right, and I already have 3 chlorines on the left. I have 1 aluminum on the left, 1 aluminum on the right, and 1 phosphate on the left, and 1 phosphate on the right. Now, because this is 2 aqueous things together, we need to figure out if one of them makes a solid. And if you check back with your solubility rules, we find that anything with sodium is soluble. Okay? And then phosphates are generally insoluble. Okay, so let's look at our next one. So again, this is 2 aqueous things, right? And this one on the right here is lead acetate. Okay, and acetate is a 1 minus. Okay, so I'm going to take and put my lead with the chlorine and my magnesium and put it with the acetate. Okay, so that means that I've got a, now if acetate is a 1 minus, and I have 2 of them, then that means that lead is a 2 plus. Right, so I'm going to have a lead 2 plus chlorine minus, and I need to put those together correctly, and then I'll have a magnesium 2 plus and an acetate, C2H3O2, 1 minus. Okay, so we want to put those 2 things, those 2 pairs of things together correctly. So my lead is a 2 plus, so that means that I need 2 chlorines to go with it. Okay, and then my acetate is a 1 minus, and my magnesium's a 2 plus, so I need 2 acetates. C2H3O2, 2. Okay? All right, so now I go through and I balance. All right, so I've got 1 magnesium on the left, 1 magnesium on the right. Good. I've got 2 chlorines on the left, 2 chlorines on the right. Good. 1 lead on the left, 1 lead on the right, 2 acetates on the left, and 2 acetates on the right. So everything is balanced. Then we go through and we do our solubility, and all acetates are aqueous. My goodness. Okay, and lead with chlorine makes a solid. Okay. Now acid-base neutralizations, and again this should be an arrow. All right, so acid plus base always makes a water and a salt. Now remember that a salt is a generic term for an ionic compound. Okay, so any ionic compound, you can also refer to it as a salt. Okay, so magnesium chloride in this example has a metal and a nonmetal, so it's ionic. and we refer to it as a salt. Okay? So acid, take a look, starts with an H. It's a dead giveaway that it's an acid. And then we have a compound with OH that makes it a base. So acid plus base makes water plus a salt. Okay, let's take a look at our ionic or our acid-base reactions here. Okay, so we have, starts with an H, we have an acid, has an OH, that's a base. Okay, and we know that one of our products when we have acid plus base is liquid water. Okay, now the beauty of these is essentially they are double displacement reactions. So I can treat them just like a double displacement. I can take my cesium and put it with my nitrate, and I take my hydrogen and put it with the OH. So that's how I get the water. H plus OH makes H2O. And then cesium is a 1 plus, and nitrate is a 1 minus, so I get cesium nitrate. And all nitrates are soluble. Okay? So let's treat the second one the same way. Let's take the hydrogen, put it with the OH, and take the magnesium and put it with the bromine. Okay? And we're going to have H plus OH, and we're going to have Mg2 plus Br minus. Okay, so again, I want to just simply put those things together correctly, and then we'll come back and balance. So we got H2O liquid as one product, and the other one is magnesium bromide, Br2. Okay, and then we come back and balance. Okay, so I've got, let's see. So I've got 2 OHs, so 2 oxygens on the right with the OH2, with this part right here. Right, so I'm going to need a 2 in front of my water to give me 2 oxygens. And that gives me 4 hydrogens. So 4 hydrogens on the right. Right now I have 3 hydrogens total on the left. Well, let's take a look. I need 2 bromines on the right and 2 bromines on the left. So let's take and put a 2 over here. And doesn't that give me 2 hydrogens with the HBr and then 2 more hydrogens with the OH? So that gives me 4 hydrogens total. And there's 1 magnesium on both sides. So there we go. All right. So let's do our third example. So KOH and H2SO4. Okay, again, I'm going to take the potassium and put it with the sulfate. So I'm going to have a K plus and an SO4 2 minus. And then I'm going to have an H plus OH. Okay? So again, it's double displacement. Hydrogen goes with the OH, potassium goes with the sulfate. All right, so we'll have H2O and K2SO4. And that will be aqueous. Anything with potassium is aqueous. So let's double check, see if we need any balancing. Let's see, we've got 2 potassiums on the right, so let's put 2 potassiums on the left. Okay, so that gives me 2 and 2. That gives me 2 OHs and 2 hydrogens, so that's a total of 4 hydrogens now. So I need a 2 here to balance those. And that takes care of my 2 oxygens there on the right and the left. I have 1 sulfate on the right and left, so we are balanced. So precipitation is essentially a double displacement reaction, and we get a precipitate from it. We get some kind of solid out of it. Okay, that's the defining characteristic there. Okay, acid-base, recognize we've got an acid plus a base, and we get water and a salt. Okay, it's also a double displacement. And then metal displacement is simply, you start with one solid metal on the left and a different solid metal on the right. Okay, so we just have a single displacement reaction right here.